So I'm recording this video on Halloween. So I have my trusty friend Liz here. And since you're probably all hyped up on candy, we're going to talk about some candy today as we review Module 4 and figure out what we can do with our candy and costumes and all of that. So we're going to take a look here. So you're going to make sure you want to have a paper and pencil so that you can practice these with me. Promise you'll do much better if you try them and not just watch me do it. So practice will help you. So Greta went trick-or-treating to 97 houses. At each house, she grabbed 0.23 pounds of candy. So she was a little greedy, it sounds like. How much candy did she get? So we are looking for the total. So I can think about this is that she went to the first house and got 0.23 pounds of candy. She went to the second house and got 0.23 pounds of candy. So I could keep on going for 97 houses, but that's a lot. I also could just think about it as she did this 97 times. So I can take 97 and times that by 0.23. I chose to put 23.23 on the bottom because it's easier to multiply by 2 and 3. So remember, we're thinking about this like 97 times 23. We're ignoring the decimal until the end. So I want you to pause the video and go ahead and try this problem here, and then come back and check your work. So 3 times 7 is 21. 3 times 9 is 27, and 2 more is 29. We've got our placeholder here. So we're now multiplying by a number that's 10 times bigger. So I need my answer to be 10 times bigger. 2 times 7 is 14. 2 times 9 is 18, plus 1 more is 19. So we're going to add up our partial products here. So 1, 9 plus 4 is 13. 9 plus 1 is 10, plus 2 more is 12. 1 plus 1 is 2. So she did not get 2,200 pounds of candy or 2,200 pounds of candy. That would be a little ridiculous and she would not be able to carry that. So I need to remember that she has this 1, 2 decimal places, 1, 2. So she has 22.31 pounds of candy. So that sounds like a more reasonable, but still very large amount of candy. Hey, let's try this one. Sal went to the store and bought 13.9 yards of blue fabric, 16.5 yards of green fabric, and 0.7 yards of red fabric for her costume. How much fabric did she buy? So we could put another word in here. How much total fabric? So I have the red, the blue, the green, and I'm putting those all together. So why don't you see if you can try that problem there and then come back and see if your answer matches to mine. So I'm going to line up 13.9 and 6.15 and 0.7. So you can notice all the ones are lined up, all the decimals are lined up, all the tenths are lined up. And I'm going to put some zeros at the end so they all end in the same place. I could put zeros here if I'd like, but I don't need to. So 0 plus 5 plus 0 is 5. 9 plus 1 is 10, plus 7 is 17. My decimal comes straight down when I'm adding and subtracting. Then I have 3 plus 1 is 4, plus 6 is 10, and 1 plus 1 is 2. So they bought 20.75 yards of fabric to make that fancy costume. Hey, Perry got 17.8 pounds of candy. So this is how much she has from trick-or-treating. And Walter got 20 pounds of candy. It wants to know what is the difference. So this word here means to subtract. We want to find out how much more Walter got than Perry. So I would take 20 because 20 is bigger and it wants to know the difference here. And I'm going to line up 17.8 underneath. The decimal on 20 is at the end of it. And then I'm going to put a 0 here so I remember that there's no tenths in this place. So if I have 0, I cannot go borrow 8. So I need to come and borrow, but I can't borrow here. So I have to come all the way to the 2 and make that a 1 and then make that a 10. I'm borrowing from the 10 to make it a 9 and a 10 here. So 10 minus 8 is 2. 9 minus 7 is 2. And nothing left over. My decimal comes straight down. So Walter had 2.2 more pounds than Perry, or I could say Perry had 2.2 fewer pounds than Walter. Hey, Velma bought 57 pounds of candy. So this is what she has. She gave away, so she's giving each trick-or-treater 0.015, 15 hundredths of a pound. So she gave the first trick-or-treater 1500. She gave the second trick-or-treater 1500. So here's her very large bowl holding her 57 pounds of candy. And the first trick-or-treater came and she gave away 1500. And then she gave this trick-or-treater 1500. So I'm trying to see how many times she can give candy to the trick-or-treaters before all the candy is gone. So I could do 57 minus 0.15 minus 0.15 and do that over and over again. But an easier way would be to divide. So we have 57, that's our total, and we're dividing it into groups of 15. Now it's pretty hard to dish out that into groups. So I want to move this decimal 10, 100, make that 100 times bigger. The decimal on 57 is at the end, so I'm going to make it 10, 100 times bigger. So we're really doing 5,700 divided by 15. So my decimal's here at the end. So pause the video and go ahead and try that. Then come back when you're ready to check. So I'm going to make myself a list of 15s here to get started. So 15, 30, 10 more is 40, and 5 is 45. 10 more is 55, 5 more is 60. 10 more is 70, 5 more is 75. 10 more is 80, and 5 more is 90. Sorry, 85, and then 5 more is 90. 10 more is 100, and 5 more is 105. Let's go one more place. 10 more is 115, and 5 more is 20. So let's see, we've gone 1, 2, 3, 4, 5, 6, 7, 8. Let's just finish it off. 135. So I will never have to make a list more than 9 long because you can only put one number above each thing. So it can never be bigger than 9 up here. It can't be 10 or 11 or anything bigger than that. So once you have a list of 9, you're done. So 15 cannot go into 5, but it can go into 57. Oh, that's too big. So 3 times. 3 times 15 was 45. Subtract, there's 2 and 1, bringing down a 0, which is exactly 8 times. 8 times 15 was exactly 120, and 0 left over. So one thing I see lots of people do is they say, oh, 15 can't go into 0, and they just say that they're done. So if I had 57 pounds of candy and I gave only 38 trick-or-treaters, that means I'm giving almost everybody a pound. And that's a lot of candy. So we need to finish the problem. Every time something goes down, something has to come up. 15 can go into 0 times. You've got to put those zeros there. 15 times 0 is 0, and there's nothing left over. So she gave candy to 380 trick-or-treaters. Greta bought a bag of candy that was $20.40, and inside the bag of candy there was 8.5 pounds. What was the cost of the candy per pound? So every time you had a pound, it wants to know how much it cost. So we're dividing by the pounds. Pounds should go on the outside. So we have 20.40 and we're dividing that by 8.5. I know I need to move the decimal one place. So I need to move the decimal one place here. So we're going to take 85 and divide it into 204. The decimal is going to come straight up. So remember, we want one thing above every number, something above the 2, the 0, the 4. Here's my decimal. I might have something after the decimal. I don't need it since it's just a 0 though. So let's make ourselves a list of 85. So 85 plus 85, there's 10, 16, 17. So we're at 170. And let's go a few more here. So another 85. There's 15, so 255. And let's go another 85 here. 10, there's 6 plus 8 is 14, so 340. Let's see if that will get us going on this problem. So I know 85 can't go into 2, and it can't go into 20. It can go into 204. That's too big. 2 times. So 2 times 85 was 170. So I have 4 left over, and 10 minus 7 was 3. So I'm bringing down this 0. I can't just say I have a remainder of 34. When it gives me my problem in a decimal, I need to give my answer in a decimal. So I can't just say remainder. If it has a decimal in the problem, give your answer as a decimal, unless it tells you otherwise. So 85 goes into 340. 1, 2, 3, exactly 4 times. So which is 340 and no remainder there. So every pound cost $2.4. So when she bought 8 of those, 8.5, that cost her $20.40. So every pound was $2.40. So it's a good idea when we're talking about money to give it 2 decimal places. Trenton bought a bag of candy that cost $23.97. He paid with $30. How much change did he get back? So we want to know. So he gave the cashier $30. His total was $23.97. How much did the cashier give him back? So go ahead and see if you can set up that problem and then come check out what I did. So I'm going to say he gave them $30. This was at the bigger number. And I'm going to take away what he spent, and that will show me what he gets back. So notice my decimals are lined up. There's a 0 above this 3, the 2's under the 3. And I put zeros above the 9 and 7 to remind myself that I don't have any pennies or dimes up here. So I cannot do 0 minus 7. So I come over and I have to borrow from the 3 and it becomes 2. So here's 10, but now I have to borrow from my 10 to give to this next one. But now I have to borrow from this 10. So finally we have 10 minus 7 is 3. 9 minus 9 is 0. 9 minus 3 is 6. 2 minus 2 is nothing. My decimal comes straight down. So they got $6. Trenton got $6.03 back. Hey, Bert went trick-or-treating. Every hour he got 4.7 pounds of candy. So he was doing this over and over again. The first hour, 4.7. Second hour, 4.7. So on and so on. After 2.75 hours, how many pounds of candy did he have? So we are looking for a total, and he does something over and over again. So we want to multiply that problem. So go ahead and try and set up that problem and then come back and see how I set it up. So I'm going to put 2.75 on the top just because it has more digits than 4.7. This way I only have to times by the 7 and the 4 instead of the 5, the 7, and the 2. So it's just a little bit less work when you put the easier problem on the bottom. So remember, we don't need to line up our decimals when we multiply. This problem is like 275 times 47, and then we'll move our decimal at the end. So go ahead and try this problem and then come back and see if our work matches up. So 7 times 5 is 35. 7 times 7 is 49, 50, 51, 52. 7 times 2 is 14, plus 5 more is 19. And then I need a placeholder to do 10 times a problem that's 10 times bigger. So 4 times 5 is 20. 4 times 7 is 28, plus 2 more is 30. So there's a lot of zeros here. And then 4 times 8, or 4 times 2 is 8, 9, 10, 11. So here I have 5, 2, 9, 2, and 1. But I have 1, 2, 3 decimal places. So 1, 2, 3. So after 2.75 hours of trick-or-treating, getting 4.7 pounds every time. So this is pretty close to 5, and this is pretty close to 3. My answer should be around 15, and I have 12.9, which is very close to 13, which is close to 15. So my answer makes sense. 12.925 sounds reasonable. Henry bought a bag of candy that cost $6.99 and another bag that cost $17.58. How much money did he spend on candy? So we are looking for our total here. So go ahead and see if you can figure out how to set this problem up and then come back and check with me. So since I'm adding, because it wants the total, this and this put together, it doesn't matter which one goes on top and bottom when you're adding. It does matter when you're subtracting. So I'm going to add these here. So 9 and my 6 and 7 are lined up because they're in the ones place. My decimals are lined up. So 9 plus 8 is 17. 9 plus 1 is 10, plus 5 is 15. Here's my place or my decimal. 6 plus 1 is 7. 7 plus 7 is 14. 1 plus 1 is 2. So he spent a total of $24.57 on candy. Hey, Frankie owned a pumpkin patch and took the people on hay rides. Every hayride could fit 18 people. So here's my hayride, and 18 people get to go on a hayride. If 298 people came to the pumpkin patch one night, so here's 298 people, and it wants to know how many hayrides did he need to give for everyone to go one time. So these 18 people went on a hayride. There's one hayride. These 18 people went on a hayride. There's 2 hayrides. These 18 people went on a hayride. There's 3 hayrides. So we could keep going and subtracting 18, but that's going to take us a while. When we're doing the same thing over and over and putting these people into groups of 18, I can divide. So 298 divided by 18. The decimal's already at the end of 18, so I don't need to move my decimal. So I need something above my 2, my 9, and my 8. So I know it can't go into 2, but it can go into 29 one time. So 1 times 18 is 18. So I'm left with 11, and I'm bringing down my 8. So I have 18 into 118. So I want you to pause the video and see if you can figure out the rest of this problem here. So I like to just pick a number, and I usually pick 5 because that's about halfway between 1 to 9. And then that kind of tells me if I need to go bigger or smaller here. So 5 times 8 is 40. 5 times 1 is 5 plus 4 is 9. So I need to go bigger here than 5. So I'm going to just try one more here. So there's 48, 6, 7, 8, 9, 10. So there's only 8 or 10 more here, so I know I can't go bigger. So here's my 6. 6 times 18 is 108. And then I have 10 left over. So remainder 10. So let's go back and look at our question. How many hay rides does he need to do for everybody to go one time? It doesn't ask how many full rides or how many full rides and a little bit. How many does he need to do so everybody can go? If he only gives 16 hay rides, he has these 10 people that are very, very sad, and they might complain and want their money back if they didn't get to go on the hay ride. So he can't just give 16 hay rides. So I want you to think, how many hay rides does he need to do so everybody can go one time? All of these people here can fit on one more hayride. So after he does the 16th hayride, he's got 10 more people and they can all fit on that next hayride. So 16 plus one more hayride is 17. He needs to give 17 hayrides in order to fit everybody on there. So he has happy customers. So when it's asking you how much you need and you're dividing, make sure you go up one so you don't leave people out. When there's people or things that get left out, you've got to go up one more, even if it's not full, so that everybody's happy. Hey, our last problem here says that Jarod set a goal to trick or treat at 350 houses. If he could go to 78 houses every hour, so he's doing that every hour, 78 houses the first hour, 78 houses the second hour, will he make his goal in 3.5 hours? If yes, how many houses did he go to? If no, how many more houses does he still need to go to? So I know he's doing this over and over again. So I can take 78 and times that by 3.5. So go ahead and pause the video and try that out and come back when you are ready to check. So 8 times 5 is 40. Here's 35 plus 4 is 39. And then I need a placeholder because I'm timesing by a number that's 10 times bigger now. 3 times 8 is 24. 3 times 7 is 21 plus 2 is 23. And now I am adding these up. So here is 13, 3, 6, 7, and 2. Now, but I have one decimal place in here. One decimal place. So he, after 3.5 hours, has been to 273 houses, which is a lot. But he did not make his goal. So no, he didn't make his goal. If no, how many more houses does he need to go to? So these words right here, how many more? See if you can set up a problem that will tell you how many more houses he needs to get to. So I would take 350 because that's what he wants, but he's only been to 273 and see how many are left to go. So we need to borrow here. 10 minus 3 is 7. And I'm borrowing here. 14 minus 7 is 7. And 2 minus 2 is nothing. So he still needs to go to 77 more houses. Remember, it took him an hour to go to 78. So he needs to go for probably about 59 more minutes to make his goal. So hopefully it doesn't get too dark before he can finish there. Okay, so that is everything for your review. So you're going to go ahead and take the review that is in Ed that's been assigned to you. And let me know if there's anything I can help you with before you take your test tomorrow. So if you are still confused about moving decimals, when you're multiplying or dividing, please let me know so we can meet before you take your test. So, and as Miss Frizzle says, don't be afraid to, what does she say? Get creative, make mistakes, take chances, make messes, something. I don't know. So, anyway.